Now we start our exercise 2.5. Question 1. Differentiate the following trigonometric functions from the first principle. Actually, in this exercise, we will differentiate our trigonometric functions. As we discussed in our basic formulas, basic 6 trigonometric formulas, on the basis of such 6 formulas, now we will start with multiple of angles or functions which consisting of sum of two functions or some operations on angles of trigonometric functions. So first of them is differentiate sine 2x. Start our process of differentiate by first principle. As we discussed in 2.1, 2.2, that these is actually consisting of 4-step process. First we have y is equal to f of x. Then we apply our first step, y plus delta y, and this will become f x plus delta x, and then delta y will be equal to fx plus delta x minus f of x. And in the next step we will divide both sides by delta x, and after that we apply limit delta x approaches to 0, so that left hand side will become dy by dx and the right hand side will give the answer of differentiation of such type of functions. So these are actually the 4-step process. Now we start. Let y is equal to sine 2x. So first step is y plus delta y. As we mentioned here, y plus delta y is equal to f of x plus delta x. So here x will replace by x plus delta x and this 2 will remain same. So the next step is delta y, and this y will become minus y sine 2x plus 2 delta x minus y. As y is equal to sine 2x, so just put the values of y in the next step. So this will become delta y is equal to sine 2x plus 2 delta x, and y will replace by sine 2x as y was equal to sine 2x. So now we come on to the simplification step. This is actually of the form sine p minus sine q, as this is the formula of sine p minus sine q, which is actually we discussed in our first year course, which is equal to 2 cos p plus q divided by 2 into sine p minus q over 2. This is actually sum to product thing, which already we discussed in first year. So this, apply the formula here, this will become sine p minus sine q. So that is actually 2 cos p. Here p is 2x plus 2 delta x plus q, which is this angle, divided by 2 sine p, which is 2x plus 2 delta x minus q divided by 2. We can compare it from this basic formula. So now by simplification, that will become delta y is equal to 2 cos. This 2x plus 2x will become 4x, and this 2 delta x divided by 2 into sine. This 2x will be cancelled out and we have 2 delta x divided by 2. Now the next step will be 2 cos 4x plus 2 delta x divided by 2 into sine. This 2 will be cancelled out, we have delta x. So we have just completed this simplification step. Now we apply both sides by delta x, dividing both sides by delta x, which will become delta y by delta x is equal to 2 cos 4x plus 2 delta x divided by 2 into sine delta x divided by delta x. This is actually of the form like 2 cos 4x plus 2 delta x divided by 2 sine delta x and whole divided by delta x. But you can see this delta x is divided only on this portion. First, if we divide anything from product of two terms, like if we divide x y divided by 2, so we can write it like x divided by 2 into y, or this can be written as x into y divided by 2. So we can apply, or we can divide this delta x either from cos 4x plus 2 delta x over 2 or sin delta x. But we divide this delta x to sin delta x over delta x, so that our basic formula of limiting theorem, which we discussed in chapter 1, that limit x approaches to 0, sin x divided by x is equal to 1. So to complete this formula, we divide delta x to this sin delta x. So now we have our next step, which is applying limit delta x approaches to 0. So applying both sides, delta x approaches to 0, delta y by delta x is equal to limit delta x approaches to 0, and the remaining thing will be as it is, 2 cos 4x plus 2 delta x by 2 into sin delta x divided by delta x. So the left hand side will become dy by dx, and on the right hand side we use our theorem on product of two functions. So limit will apply on this part and on this part separately. So that will become dy by dx, which is left hand side. The definition of actually dy by dx is equal to, when we apply delta x approaches to 0 on this part, this delta x will become 0. We have 4x divided by 2, which is this one, into, when we apply limit here, so this will become actually limit delta x approaches to 0 sin delta x whole divided by delta x, and this thing will become 1. So that is actually this one from limit delta x approaches to 0 sin delta x over delta x, which explained here in this step. So this 2's are 4, and our final result is actually 2 cos 2x. So the derivative of sin 2x, sorry, this is not y, we have d by dx of function, the value of y actually, so y will not appear here, that is actually sin 2x, and this will become 2 cos 2x. So from this result we can conclude that we know that derivative of simple sin x, which we proved in our theorems, that is actually cos x. So the formula of derivative of sin x is equal to cos x. But now we have derivative of sin 2x here, 2 cos 2x. So we may conclude that this is actually happened like this, sin 2x. So first we apply derivative of trigonometric functions, which will become, by using this formula, derivative of sin x is equal to cos x. So derivative of sin 2x will become cos 2x. But next derivative will apply on angle, so that will become actually d by dx of 2x. So this cos 2x will be as it is, and derivative of 2x, 2 is the constant term, and derivative of x will be 1, so that is actually 2, and final result will be 2 cos 2x. So this is actually the explanation of this result, that whenever we have a trigonometric functions with multiple of angle or angle other than x, then derivative will apply in such a process that first we apply derivative on trigonometric functions, so that is actually cos 2x, and then derivative will apply on angle, so 2x, a derivative of 2x will become 2. So this is actually the whole derivative of sin 2x, 2 cos 2x.